Thinking about factoring the greatest common factor, or GCF, out of the binomial 3x plus 6, I need to be thinking about common factors between the two terms of the binomial. When I take a look at some possible factorizations of 6, I know that 2 times 3 is 6. When I factor 3 times x into literally 3 times x, I can see that the common factor here will be 3. So that when I have factored that out, I get 3 times the binomial x plus 2. Many students prefer to think of this as distributive property in reverse. And you can see that if I choose to use distributive property, I'll get back to where I started. In the problem 8x plus 12, this particular polynomial expression is also a binomial. And when I start to think about some possible factorizations of 12 and 8, it's obvious that they're both even numbers. And so right away, I think that potentially 2 might be a common factor. And indeed it is. However, it is not the greatest common factor. So if I wanted to start this problem over, instead of choosing 2 times 6, I might choose 3 times 4 to rewrite as 12. And now I have a new common factor which is larger than 2, and it's 4. When I factor that out, I get 4 times the quantity, 2x plus 3. This is the greatest common factor, and I know that because when I look at the binomial inside the parentheses, I have no more common factors. I just have factors of 2, x, and 3. None of them are the same. So I have factored out the greatest common factor, or GCF. In this next problem, I actually have a trinomial. So what I need to do is I need to be thinking about common factors. And right away, I can look at 6b and negative 12c, and I might think of 6, but 3a would not have that same common factor. So I'm probably going to have to settle for looking for something like a 3. So let's see what we have here. If I take this 3 and combine it like this, then combine it again, I can see that what I have is 3 times the quantity, a plus 2b plus negative 4c.